Alright, for our quiz 4 here, first of all we got to determine whether or not the following distribution is a probability distribution or not, and explain your answer. So here for this, you need to decide if whenever you add up those probabilities, if they add up to 1 or not. So here in this case, if we add up all these probabilities here, looks like we get 0.98. for that sum. So here in this case, then we'd have that no, it's not a probability distribution. And for a reason, you're going to put because the sum here of our probabilities, our p of x, which remember represents your probabilities of those x's, does not equal 1. But remember, whenever you are checking to see if it's a probability distribution, you need to have that sum be equal to exactly 1, and you would also need, in general, for those probabilities, always have to be between 0 and 1 in order to be a probability distribution. So let's write here that we need probabilities to be between 0 and 1, and we would need the probabilities to add up to 1 for it to be a probability distribution. So make sure and keep that in mind whenever you're checking that you're checking both of those conditions. Both have to be true in order for it to be a probability distribution. So for instance, if there was a negative probability, it would not be a probability distribution. Or if you had one that was more than 1, it's still not a probability distribution. Even if they happen to add up to 1, still would not be if they're not between 0 and 1 for each of those individual probabilities. So for the next one, to find the expected value of the probability distribution, that's the same thing as finding the mean of the probability distribution. So to find that, what we need to do is do the sum of what we'd get whenever we do our x times our probability of our x's. So here, one way to go through and write this up is to go through and multiply each of those first, and then add all those up. So here, for instance, 0 times 0.23 is 0, 1 times 0.23 is 0.23, 2 times 0.22 is 0.44, your 3 times 0.12 is 0.36, and 4 times 0.2 is 0.8. Should say 0.8 there. Got a little bit better there. So then if you add up your 0, your 0.23, the 0.44, the 0.36, and your 0.8 there, once you add all those up here, you should get 1.83 for your final answer, it looks like. And of course, like normal, make sure that you are showing all of your work as you're doing these, and explaining your answers for the ones where I ask you to explain them. The last one here is going through trying to decide if this is a probability distribution, or if this case is a binomial experiment. So remember, the different types of experiments we had here were our binomial, geometric, and Poisson distributions. The ones that were most similar to each other were the binomial and geometric. For the Poisson, if it's a Poisson distribution, you have to have something in there about a mean or an average of those values. And just a reminder here also, you can reference that on page 221 in the book. It has a chart that kind of separates those 3 different types of distributions. For the quiz, you don't have to know the formulas for the probabilities there, but on the test you will. So you want to make sure, first of all, here for the quiz, You're learning the difference between those. So here in this case, if it's not a binomial distribution or a binomial experiment, we want to identify which property is not satisfied and what type of experiment it is. And if it is a binomial, we want to list the values of n, p, and q, and then the values that your x can assume. So here, whenever we're going through this, okay, for a minute, we'll type it out. So here we have that a fair coin is tossed until you flip a heads. So you keep flipping this coin until you get a heads. So we don't know how many times you're going to flip it. So in this case, then we don't know what n is. N, remember, represents the number of trials, the number of times that you're doing it. So in order for it to be binomial, you would have to know what your n is, how many times you're going to do this. So in this case, we have then that it's not a binomial, since you don't know what n is, which remember is the number of trials. In this case, it would be geometric, since you go until you get a success, which in this case, the success is flipping a heads on that coin. So the main difference between your binomial and geometric, once again, is how many times you're doing it. If you know exactly how many times you're doing it, like if I said you're flipping the coin 10 times and seeing how many heads you have, that is different than you flipping the coin until you get a heads. So make sure you're reading those carefully. And if I said the average number of times that you got a heads whenever you flip 10 coins, then that would be a Poisson distribution instead, if we're talking about the average number of times. So remember, like normal, if you do have questions, make sure you are asking before the quiz.